the first card was king, then the conditional probability of the second card is king is equal to 3 over 51. So we label this branch with 3 over 51. And if the first card is king, then what is the conditional probability that the second card is not king? How many? How many non-kings available for the second draw? 48, right? Because we don't touch the non-kings in the first draw. We just drew a king in the first draw. So for the second draw, we have the 48 non-kings. So this conditional probability is 48 over 51. Now, if the first card was not king, we also have two different outcomes for the second draw. Either the second draw is a king, or the second draw is not a king. Now let's look at the conditional probability of the event the second card is king, given that the first card was not a king. So for this second draw, how many kings available? 4, right? We have the 4 kings available because we don't touch king in the first draw. And totally we have the 51 cards available. So it's the 4 over 51. Then how many non-kings available for the second draw? 47. Okay, so 47 over 51. Then we finish the tree diagram for this problem. And this just tells us the relationship between the results in the first stage and the second stage. And this tree diagram is very useful for the conditional probability. And for this problem, I add one more part, part E. So in part E, I want to find the probability of the event that second card is king. So find the probability of K2. To find this probability of the event in the second stage, we need to draw a Venn diagram to help us. So let's first draw a Venn diagram. And we have K1 and its complement divide this whole sample space into 2 parts. This K1 and this K1 prime. And K1 and the K1 prime also divides K2, whole thing, this guy is K2, into 2 parts. This part is K1 intersection K2. And this part is K1 prime intersection K2. So now we may use equation to express this result. So that means K2 that should be equal to the union of this part and this part, which are mutually exclusive. So we have K1 intersection K2, this part, union K1 prime intersection K2, that is this part, and the intersection of these 2 parts are, is equal to the empty set. So you have the K1 intersection K2 intersection K1 prime intersection K2 is equal to empty set. And we have the one rule for two mutually exclusive sets. Right now we know this guy and this guy are mutually exclusive. So if E and F are mutually exclusive, then we have P of E union F is equal to P of E plus P of F. And this is rule 5. Now, applying this rule 5 onto this K2, so we have P of K2 that is equal to P of K1 intersection K2 plus P of K1 prime intersection K2. So P of K1 intersection K2, which we already found in part C, right? So now we just need to find the P of K1 prime intersection K2. So this P of K1 prime intersection K2, we know this is the probability of the intersection of these two events. That is, the first is not a kin. Intersection, the second is a kin. Right? And let's first look at the P of K1 prime. What is the P of K1 prime? The first is not a kin. What is the probability of the event the first car is not a kin? Let's go to the tree diagram. The first car is not a kin, 48 over 52. Okay, so this is equal to 48 over 52. And what is the conditional probability that second car is kin, given that the first car was not kin? So this conditional probability of K2 given that K1 prime. So go back to the tree diagram. The first car was not a kin, and the second car is a kin. So this conditional probability is equal to 4 over 51. Now, by the product rule, P of K1 prime intersection K2 is equal to P of K2 given that K1 prime times P of K1 prime. And this is equal to 4 over 51 times 48 over 52. So now, in this expression, we find the P of K1 intersection K2, which is obtained in the part C, and also here we find the probability of K1 prime intersection K2. So P of K2, which is equal to the sum of P of K1 intersection K2, and this is equal to 1 over 221. m plus p of k1 prime intersection k2, that is equal to 4 over 51 times 48 over 52. Then you simplify, you get 1 over 30, and this is approximately equal to 0.076923 something.